This video is to show you how to read data to FLUX for assignment number 2. Here we're using data from the Little Cannon River. So you go to the Data tab, go to Read, New Sample Data and Flow Data, and then New Stratification. And what it's going to ask for are 2 data files. If you have your daily flow data in a separate file from the sample data, then it's going to ask you to read 2 files for input. And the flow data file is going to be the first one that you'll be reading. So the flow data file for this assignment is Little Cannon flow data updated. And then it's going to ask you to select the file with the sample data. And that one is Little Cannon River Water Chemistry Data Assignment 2. So it immediately goes and it's going to ask you from the flow data file which column and numbers you want to use, and in this case it's the Little Cannon flow. The first column is the data in which flows were measured. So read 3,554 data values. And now it's going to be reading the sample data file, and it just asks you about whether using the column labels as for site identifiers, and we'll just say yes here. You see there's a bunch of different things to select from. The data collected is date. We have the TSS, TBS would be total volatile solid. SSC is the suspended sediment concentration. We're going to use TSS in the assignment, although we do have values for SSC, which might be a better number to use in our analysis, but we'll use TSS. And then total phosphorus and nitrate. And then because there are no flow data in the sample data file, we have to correspondingly determine for a given date what the flow is, and we're going to let FLUX do that automatically for us. It will search through the flow data file to match up the sample dates with the flow dates. So it's asking here for the sample flow field, and we choose that first. That's where the flow is going to come from. And then ask for a constituent. In the first, you're going to do this for TSS, total phosphorus, and nitrate. Here we'll use TSS. We're going to do the TSS in the first part of the assignment. Okay, so it says it's not able to find a matching daily flow for sample on October 30th, 2007, and that's because if you look at the flow data file, there is no discharge on that date. For some reason, the data is missing. It was a bad day for flow measurement. And there are 7 of these in the data file. So you could just sit here and say yes, and we'll do it again. There's no data for May 7th, 2010. There are 7 values in total. You could just say yes to all, especially if there's a large number of them. There are 117 observations for input. So what we're saying there is that there are 117 dates of sample for which there are flow data available. There are actually more sample dates than that, but there are only 117 in which there's a matching flow value. Now, one could go into the sample data file and estimate what the flow is for those dates in which flow is missing, but we're not going to do that here in the assignment. All right, so it says most grab sample flows are missing. Do you want to substitute daily flow for those missing grab sample flow values? And the answer is yes. And the data is going to come from Little Cannon flow data file. Says that the original flow data files are not sampled according to date, and that's true. If you look at the flow data, there's some mix-up in the dates. But what we'll do here is we'll have FLUX do that sorting now. Now it's going to tell you that some of the samples, they're duplicate samples taken on a given date. And so you could use the exclude a value, you could use the average of values, and so on. So you could just exclude the data altogether. You could use the average, and I'll just suggest that we use the average. And we could do that one at a time, but you see that there's a number of, there actually were a couple of those in there. And if there are a lot of them, that you just click that little box that says don't open that window again, or don't tell me again, and it'll just do it for all of them automatically. So what we get here then is we get the summary, which shows that the cubic feet per second is the discharge unit, and the same for the sampling flow. It's important to have these units correct, because FLUX does a conversion to million cubic meters per year, and for CFS, this is the conversion factor. And it's also important for the sample data to have the units correct. TSS are measured in milligram per liter. FLUX converts those values to part per billion, or micrograms per liter. What's indicated here for the daily flows, there are 3,554 values of them. The mean flow was 63 cubic feet per second. The maximum discharge was 2708 cubic feet per second. For TSS, it says here milligram per liter, but actually the numbers that are given here for the mean and the maximum are microgram per liter. So it's already done that conversion of milligram per liter to microgram per liter, because the maximum that's given is 3,580 milligram per liter. Not sure why FLUX lists the values as this, because it says that it's supposedly in milligram per liter. The actual maximum constituent concentration, if you look at the sample data file, is about 4,900 milligram per liter, but there were two values taken on that same day. One was 4,900 and the other was 1,300, and when we averaged, it made it less than the 3,580, which was the other maximum, or which was the other highest value that was in the sample data. So it lists the maximum concentration as 3,580 milligram per liter, not the 4,900. Okay, then we say done, and so if we want to, we can do a quick plot of the data. So you can see the flow data, you can see the sample data. The maximum sample value is this 3,580 over here on the right-hand side. You have some statistics here that are shown in this window for the flow data. And then, of course, what we can do is we can go immediately on and do things like load calculations and the other procedures that I've already spelled out in other video for you. Okay, so that should help you to get your data loaded for the FLUX assignment, for assignment number 2.